Hey guys, today we're going to learn about our trig ratios, and it's going to be awesome. So here's our trig ratios. We have sine, we got cosine, we got tangent. You've probably seen those buttons on your calculator and like, what do these do? Well, I'm not going to teach you all that today, but I'm going to teach you what those ratios mean. So we're going to be comparing sides of a triangle, specifically a right triangle. So you see our right triangle over here. Hi, right triangle. Hello. So we're going to be using him for the examples. Excuse me. So the first ratio we're going to talk about is called sine. Sorry. Yeah, yum. So the sine ratio is the opposite leg over the hypotenuse. What opposite leg? The opposite leg of some angle. This is called a theta, and it represents an angle. So when I talk about the sine ratio, I'm saying, hey, from some angle. So let's look at our first example. Our first example says sine of A. So what I need to do is I need to be like, hey, this is all about angle A. So when I talk about opposite, I mean what side is opposite of angle A? So I got three choices, X, Y, and Z. So when I talk about the opposite leg, the two legs are X and Y because Z is a hypotenuse. So Y would be considered the adjacent leg to A because that leg is actually touching angle A. Side X over here, side BC, which has an X on it, would be considered the opposite side. It's the side that's not touching angle A. It touches B, it touches C, it doesn't touch A. That's the opposite side. Some students like to draw a little arrow and be like, hey, that's the opposite. So I know that this is the opposite side. And I also know that Z is the hypotenuse. How do we know Z is the hypotenuse? Because it looks the longest. It does look the longest, but it's also opposite the right angle, or the right angle points the way to the hypotenuse. So the little point on the right angle always points you to the hypotenuse. So I know that Z is the hypotenuse of that triangle. So when I talk about sine of angle A, the opposite leg is X, and the hypotenuse is Z. Boop, boop, boop. So the ratio looks kind of weird because I'm just putting letters in here. But in the next example, we'll use numbers, and it'll be awesome. So up next is cosine. If I talk about cosine, that ratio is the adjacent leg. So that means cosine of some angle is equal to the adjacent leg to that angle over the hypotenuse. So if I look at my example, I need the adjacent leg to A. We're doing cosine of A. So I come over here, my triangle, and I'm like, okay, I got angle A, it's already circled, and I need the leg that's adjacent to it. So the word adjacent, little reminder, means next to. Oopsie. Means next to. Okay? And the side that's next to angle A would be that side. It has a Y on it, side AC. So we will label that the adjacent side. ADJ for adjacent. So when I write my ratio, cosine of A would be the adjacent side, Y over the hypotenuse, still Z. So cosine of A would be Y over Z. Wow, this is fun. Then last up, you have your tangent ratio, which is the opposite leg over the hypotenuse. So I'll be like, tangent of some angle is the leg that's opposite that angle over the, oops, I wrote hypotenuse. That's not right. Adjacent leg. Come on. So tangent is opposite over adjacent. Okay. So still going from angle A, right. Tangent of A. equals the opposite. Well, we already got that labeled. Opposite of A is this side we're calling X. So tangent is X over, and then we need the adjacent leg to A. Well, adjacent means next to, and the leg that's next to angle A would be this one right here, which has a Y on it. So tangent will be X over Y. Boom! So we got our three ratios: sine, cosine, tangent. And you guys are probably thinking, I'm never going to remember this. Don't worry. I'll teach you. That's my job. So one way we can remember it is by the old saying, so ka toa. So ka toa, so ka toa. And that helps us remember that sine is the opposite over the hypotenuse. That cosine is the adjacent over the hypotenuse, and that tangent is the opposite over the adjacent. SOHCAHTOA, SOHCAHTOA. Plus, it's really fun to say. So SOHCAHTOA is going to help us on the first example that we do here, now that we know our trig ratios. So let's do it. Our first example, I'm going to write example uno. And I'm also going to write SOHCAHTOA up top. SOHCAHTOA. And I kind of expect that you write that on your assignments. Like, why not? It's going to help you. So when I talk about sine of A, sine makes me think of makes me think of SOH. So. And I know that sine is opposite. So I need the opposite of A over the hypotenuse. I got the O and I got the H. So you can see how the SOH, reminded me that sine is opposite over hypotenuse. Now I'm going to come over to my triangle and I'll be like, hey, triangle, we're talking about angle A. It's all about A. So from angle A, I need the opposite leg. Is it 12? Is it 13? Is it 5? Well, I do know. It's my job to know. So it's not 12 because 12 is the adjacent leg. It's not 13 because 13 is the hypotenuse. As you can see, the 5 is opposite the A. You can also tell because that length of 5 doesn't touch the A. Touches B, touches C. So that's the opposite. So the opposite is 5. And the hypotenuse, remember the right angle points to the hypotenuse. So the right angle is pointing to 13. So sine of angle A is 5 over 13. Yes! Next, cosine of A. So when I see cosine, I'm thinking ka. So cosine is adjacent over hypotenuse. Adjacent of A. So adjacent means next to. So I see a 12 and a 13 next to A. Is it the 12 or is it the 13? Well, it's not the 13 because the 13's opposite the right angle. It's the hypotenuse. It always will be if it's opposite the right angle. But the 12. The 12's not the hypotenuse. It's a leg. And it is next to A. So the adjacent is 12 and the hypotenuse is still 13. So cosine of A is 12 over 13. And then last up, tangent of A. So that's the toa. So tangent is opposite over adjacent. I keep wanting to mess that one up. Don't do it. So what's opposite of A? Because remember, it's all about A. Opposite of A, well, it's 5. It's 5 because the 12 is adjacent to A. So it's 5 over 12. That's what we got. All right, so all of that is good. I got sine, cosine, tangent, all about angle A, but then the game changes. Oh, no. Yeah, it changes because now we're talking about C. So I want sine. I want So I want the opposite over the hypotenuse, but this time it's all about angle C. So I'm going to circle angle C. I'm not going to pay attention to A anymore. Get out of here, A. You're old news. So from angle C, we need the opposite. What is opposite of C? Well, it's the one that doesn't touch the C. The only one that doesn't touch C is the 12. It is opposite. So don't mind all my little arrows. I'm just trying to explain my work here. Don't let it confuse you. So the opposite is 12, and the hypotenuse, guess what? It's still 13. It's not like it's going to change. The hypotenuse is the hypotenuse. Cosine, so that's the ka. So adjacent over hypotenuse, ka. And the adjacent leg to C, well, it's not 13 because 13 is the hypotenuse. So it's got to be the 5. That's the one that's next to C. And then the hypotenuse is still 13. And then last up is tangent C, which means toa. So it's opposite over adjacent. And the opposite of C, we already said was 12. And the adjacent, the one next to it, is 5. The hypotenuse doesn't get used with tangent. So we are done. We got sine, cosine, tangent of A. We got sine, cosine, tangent of C. Now, what you might see, what you might notice, there's some connections here. You might notice that cosine of A is the same thing as sine of C. What? You might notice that sine of A is the same thing as cosine of C. And it's always going to be like that. That little pattern is always going to happen. So if I had, I don't know, some other triangle, well, let's call it MAT. So if I talked about sine of angle M, just like we saw here, sine of angle A was the same thing as cosine of C. That relationship always happens. So sine of this angle is going to be the same thing as the cosine of the other angle, cosine of T. Just something to be aware of. So just be on the lookout for that, because that happens. Okie dokie. Well, the next one we should probably chat about the next one. So follow me to the next one. Here's the next one. The reason I wanted to talk about this with you guys is because we're missing something. We're missing a piece of the triangle, but we're really smart. Like, we're really, really smart. I know if I have two sides of a triangle, I can find the third using Pythagorean Theorem. With an exclamation mark. And you guys know it's a squared plus b squared equals the c squared. And we also know that c has to be the hypotenuse. And we also know that the hypotenuse is always opposite the right angle. So the c side is the one we don't know. And then a and b can be the others, whatever. It doesn't matter. A can be 9, b can be 12. So I could say 9 squared plus 12 squared equals c squared. Okay, so that's an 81 plus a 144 equals c squared. And we can do a little simplifying. 81 and 144 makes 225. And to solve a square, we use a square root. And that comes out really nice because the square root of c squared is just c, and the square root of 225 is 15. So I know that that length is 15. Got to be good at Pythagorean Theorem. If you learn anything from me this year, I hope it's Pythagorean Theorem. All right, so now that I know that, now I can answer all these questions. Now you can answer all these questions. So if you want, you can pause the video and you can go ahead and knock it all out. Or if you don't feel ready for it, then just follow along. And you can pause it for the next example. All right. Well, I'm going to start explaining it now. So if you paused it, hopefully you got them all right. If you didn't pause it, then listen close, because here's how we do it. Sine of W, so from angle W. Sine is so. So I need the opposite over the hypotenuse. When I hear the word sine, that's my go-to. So I need the opposite over hypotenuse. Well, opposite of W is the one that doesn't touch it. So it's not 9, it's not 15, it's got to be 12. And the hypotenuse, remember, the right angle points the way. 15. All right, now we got cosine of W. So when I think cosine, I think ka. So that's adjacent, A for adjacent. And H still means hypotenuse. So the adjacent leg is the leg that touches the W. And in this case, that's a 9er. Because 15 is still the hypotenuse. And then last up, tangent of W. When I think tangent, I think toa. So opposite over adjacent. And the opposite of W is still 12. It was 12 a couple seconds ago. It's still 12. And the adjacent is still 9. So there you go. Sine W, cosine W. There it is. And I know I could reduce all of those fractions, but you guys can do that. You're big kids. Now, if we're going to do the x's here, sine x, cosine x, tangent of x, then I'm not going to look at W anymore. W, get out of here. It's all about x. Okay? So now when I talk about sine being opposite over hypotenuse, I'm going from angle x's point of view. So the opposite of x isn't 12 anymore. It's a different angle. So opposite is going to be a 9er. 9. Why is it 9? Because 9 is the side that doesn't touch the x. Oh, I get it now. Sure. So 9 is the opposite, and the hypotenuse is still 15. And you might notice, hey, I knew that was going to happen because sine x is going to be the same thing as the cosine of W. True story. Well, if you use that logic, then you probably already know that cosine of x should be 12 over 15. We're going to check, but that shortcut says that cosine of x should be the same as sine of W. Let's check it, though. Cosine should be adjacent over hypotenuse. The adjacent of x, what's next to x, is 12, and the hypotenuse, okay, yeah. The shortcut checks out. It works. And then last up, tangent of x is opposite toa, right? Opposite over adjacent. So, what's opposite of x? It's a 9. What's adjacent to x? It's a 12. The hypotenuse didn't get used because it doesn't in tangent. All right, y'all. So hopefully that helped. I'm not going to explain the next one. I'm going to show it and then show the answer. Trying to keep this video under 20 minutes. Here we go. All right, so you might want to pause it because I'm going to show the answers in like just a second. So pause now. All right, so here's the answers, and my work is kind of shown. I hope you learned something from this video. If you didn't, I'm sorry. Get all your money back. All right, have a wonderful day, or night, or morning, or whatever time it is that you're watching this.